Good evening everyone. I am Sanjay Nanvi. Today I am presenting our assignments, ATC assignment, Structural and Computational Representation of a C program using an CPG analyzer. So the main objective of this project is to understand how the C program it can be represented internally using the different computational models. Instead of simply executing the inputs, we studied its structure, control flow and data relationships. So for this purpose, we developed a website that accepts the C program as an input and it generates a various representations such as lexical analysis, uh, abstract syntax tree and data flow graph as well as code property graph. So when the programmer writes the code, the computer it do not understand it directly. The code it must pass through the several stages of analysis before the execution. Understanding these steps it is important because they are used in compiler designing, static code analysis, program optimization and software maintenance. So our project it visualizes these concepts in an interactive manner. So So our objective is to analyze the C program structurally and computationally, and it generates the different representation automatically, and to understand how the programmer proceeded internally to develop an user-friendly relationship between syntax, data flow, and control flow graph. So our website acts as an analyzer. It analyzes the C code, means when the user simply enters the C code into input area and clicks the analyze button, the system it processes the code and it generates the multiple output automatically. The website it consists of front end for the user interaction and graph generation modules and visualization components. The main advantage is for the student it can understand the compiler concept visually rather than theoretically. So the workflow of our project is when the user enters the C program, the first phase lexical analysis is performed, then the parser it generates an abstract syntax tree, then the control flow graph is constructed, the data dependencies are analyzed to perform the data flow graph, then AST, CFG and DFG, which means that abstract syntax tree and control flow graph and data flow graph, they are combined to create the code property graph. Thus, the source code is transformed into the different representation step by step. Now, I will explain how our website will work. So, it is the first we enter a C program here. So, this is the text box where we enters the C program. So this is the input area where we give a sample C program. So I enter an C program here, and after clicking the analyze button, then it will generate the sequential output. The output it can be viewed individually for better understanding, as well as this interactive approaches makes learning easier compared to study the diagrams from the textbooks. So when I click the analyze button, it automatically generates the lexical analysis where the tokens as well as category are mentioned here. Then it will construct an abstract syntax tree. Then the control flow graph as well as the data flow graph is constructed. Then the last, all combining the AST and the CFG as well as DFG, which called as code property graph, is constructed like this. So this is the sample C program which declares the three variables, variable A, B and C. Then it is initialized. The program it checks the condition like if the A is less than B, then if the condition is true, then C is equals to A plus B. Otherwise C is equals to A minus B. So finally the value of the C is printed here. Then The lexical analysis. Lexical analysis, it is the first phase of the compilation. In this stage, the source code is divided into smaller units called as tokens. So, for example, it includes keywords, punctuation, identifiers, and etc. It also includes the constants. Our output shows the 51 tokens which has 7 keywords and 12 identifiers. So for example, here int, it is recognized as a keyword. And the main, it has an identifier, and the greater than symbol, it is recognized as an operator. Here the lexical analysis will analyze each tokens. The hash include stdio.h, which it represents the type of the tokens as well as the category which it belongs to. So hash include, it belongs to the type like preprocessor, and it belongs to the category called preprocessor directive. So int and main, it is the type of keyword which we can use here, and it is the reverse word, and the parentheses and the flower brackets, these are the closing it is a opening and closing parenthesis, which is a type of a punctuator, and again the int, it is a keyword. Then a, which is an identifier, it is a category belongs to the variable. So then equals to, it is an operator, it is a type of operator. Then the category belongs to the arithmetic or a relational operator, and the phi, it is an integer, and it belongs to the category called numeric constant. And next the comma, and like this, then it comes for the conditional statement. If it identifies as a keyword and it belongs to the category called reverse word, then the less than symbol, which is an operator, it also belongs to a category called relational or an arithmetic operator. Then like this, it will analyze all the tokens into the types as well as which category it belongs to. Next, the printf, it is the keyword. Then the percentage d, it is the string, and it belongs to the category string literal. Then the return keyword, and the 0 is an integer which is a numerical constant, and it will analyze each and every token of the code, and it divides like a type which it belongs to as well as the category. Next, the abstract syntax tree. So this graph, which represents the abstract syntax tree, which shows the hierarchical structure of the program based on its syntax. So the construction of the abstract, it begins after the lexical analysis. Once the source code, it is divided into the tokens, the parser, it applies the grammar rules and the C language to organize these tokens into the tree structures. So at the top we have the program node, which acts as the root node of the tree. So the program node, it is divided into the two parts, the preprocessor directive as well as the main function. The preprocessor directive, which includes the hash include stdio.h and the main function. So inside the main function, we analyze and creates the block node representing the body of the function. The block node is further divided into the declaration statement and if statement, return statement, as well as assignment. So the declaration node, it contains the variable a, b and c. The variable a is assigned to the integer value 5, which is represented in the green color, and the variable b is assigned to the value integer 10. So then the if statement node, it is divided into the three parts: the condition part, then block, as well as the else block. The condition node, it contains the operator less than operator whose operands are variable a and b. If the condition is true, then the then this block will execute. Here the analyzer, it creates the assignment node for the c is equals to a plus b. The additional operator here, it is a node for the variable a and b. Then a and b becomes the child node. Similarly, in the else block, in the else block, the analyzer, it creates another assignment node for the c is equals to a minus b. So where the operand subtraction operator is the parent node and the variable ab is the child node. Finally, the return node, it contains the integer value 0. Therefore, the AST is constructed by the following the syntax, the structure of the source code, and it helps us to understand how the program is organized grammatically. Then coming to the control flow graph. So this graph is the control flow graph, which shows the sequential in which statements are executed. So the analyzer, it constructs this graph by examining the execution order of the program. So execution begins at the start node, then the next node is the decision node, which containing the condition a less than b. Since the condition statement, the analyzer creates two outgoing edges. One of the is true branch and another one is false branch. If the condition will be true, then the control moves to then block, which is c is equals to a plus b, is executed. If the condition is false, then the a minus b node is executed. After executor either of the batch, the two paths will be merged in the printf statement. Then the control then proceeds to the return 0 statement, and finally the execution reaches to the end node. Thus the CFG is constructed by executing these statement according to execution sequence and branching behavior. So this graph, it helps us to identify the possible execution paths. Next, coming to the data flow graph, which focuses on how the information move between the variables. The analyzer constructs this graph by identifying the definitions and as well as the uses of variables. So the graph, which begins at the entry point, the first node contains the declaration a is equals to b and b equal to 10 as well as the variable c. So these statements define the value of a and b. These and the next, the condition a less than b uses the value variable a and b. The analyzer traces these data dependencies, creates the edges from the variable definition for their uses. If the condition evaluates as true, the variable a and b flow into the expression a plus b, proceeding a value and assign it to the c. If the condition evaluate false, then the a and b flows into the expression a minus b, which result is stored in the c. The value of stored result then passed to the printf statement. Finally, then it will pass into the return statement. Finally, the program executes the return 0 and reaches the entry point. So DFG is constructed by tracking where the variables are defined and uh, where they are subsequently used. So this graph helps us to understand the dependencies within the program. Next coming to the CPG, which is a code property graph. So it combines the information of abstract syntax tree and CPG as well as data flow. The analyzer first generates the AST and the CFG and DFG. These graphs, they are merged using a common program element as statement, variable as well as conditions. So in the center we can observe the AST layer, which provide the structural and hierarchical of the program, and on the left side we can see the CFG layer, which shows how the control flow through the different execution. And next we can see the DFG layer on the right side, which illustrate how the data moves between the variables and statements. So these connection between these layer, it creates a unified graph called as code property graph, From example A less than B, then exist the three representation AST, CFG and DFG. So similarly the assignment statement, they are linked across all the layers. Thus, the CPG provides a complete understanding of the programming by integrating program structure, execution behavior, and the data relationships. So this representation, it is widely used in the static code analysis and also the malware analysis and the software security research also. So overall, this assignment this assignment help us to learn help us to understand how the C program analyzed beyond the final output. Though this project we studied different representation of the same program, the AST, CFG and the code property graph as well as DFG are integrated. All these represent into the unified model. By implementing and analyzing these graphs, we gained a practical knowledge of concept related to the compiler design, static code analysis as well as software security. So, uh, so it successfully achieved its objective of transferring the C program into a multiple analytics representation, and it and also enabling to understand not only what the program does, but also it organized, executed, and analyzed internally. Thank you.